my talk's going to be about cloud host-based strategy by staging defensive tools for threat hunting and forensics. Who am I? My name is Michael Mimo. I'm the Chief Security Officer of Copyright Clearance Center. You can follow me on Security DevOps on Twitter, and I've had various different roles doing cybersecurity in the past. I'd say in the past 7-8 years, really focused on the defensive side. All right, just a quick disclaimer: none of the tools or vendors presented in this are an endorsement, and there are many different tools that you can use to achieve the same goals that I'm going to talk about here. And my talk is very much focused on AWS, but I think these concepts could be applied to any cloud provider. All right, so the problem statement. How do you scale at an enterprise level forensics and threat hunting in the cloud, right? So I was thinking about how best to present this, and I think one metaphor that I can use here is every year my son and I go to this gaming convention, and one of the games that we play there is this Axis and Allies at the Sea game, and what happens in that game is we simulate the Battle of Midway, right? And the Battle of Midway was a World War II battle between the Japanese and the United States, and couple of things that happen in that game that are quite interesting is, for instance, the initiative, right? Who gets to go first? If you win initiative, you're actually not the first to move, and it's actually a disadvantage for you to move first. And that's sort of similar to what happens in the real world, right? So your attackers make the first move, and you have to, you have to react to that. Also, there's stealth involved here, right? So you don't want the enemy to find your ships before you find theirs. So that's also an element of how cybersecurity and the defensive side works, and especially when you're doing threat hunting and the reconnaissance, right? I mean, there's the another way of saying that is doing threat hunting. And I was told a few years ago that by a cybercom person who worked on the United States NSA that where did threat hunting come from? It was one of these techniques that was developed during World War II, and maybe it was done before that, but the United States used it in World War II to test their sentry points. So they would have sentry points defending the perimeter of, where their troops were, and you would send your own troops into to test those sentry points to see just how awake and reactive they were. So with that in mind, let's talk about the good old days, right? Traditional forensics environments. What were they like? You had these forensic towers, and you would sit at your desk, and you would use that forensic tower to connect to your LAN, which you oftentimes in the office you would have access to anything on that LAN in your office to be able to connect to it and use your forensic tower and the software that's on there to conduct forensics. Or if you end up confiscating hard drives and computers, you would use a write blocker and connect that write blocker to your computer and examine the evidence there. Also, a lot of the forensic software was pretty much only activated if you use a dongle. So you'd have to connect the dongle to your forensic tower in order to use that. So, but here we are in the Neowise days. Things are different now, right? So host forensics, you're going to have to do it in the cloud now. A lot of the infrastructure, especially on the product side, is moved to a SaaS-based type infrastructure in the cloud. And, you don't have access any longer on the LAN to everything. There's a lot of, access control lists and security groups, and things might be in multiple VPCs. This makes it a bit of a challenge when you're in the cloud and you're trying to conduct forensics. Also, you need to really think about cloud automation, right? I mean, you're not going to manually be going in there and changing settings or opening security groups. You need to find some way to automate that. And you need to put in continuous integration, continuous deployment into the pipeline for your security defenses, right? That's a really important aspect of this. And this is one area that I'm going to talk about a lot in the second half of this talk. And at the end of the day, security is everyone's problem. It's not no longer the security teams are responsible for that. The DevOps teams, the operations teams, the business, we're all very, very much need to be aware of what's the best way to implement security. So I want to talk a little bit about the shared responsibility model with cloud providers, especially with AWS. So basically one way to look at this is like, the orange here is AWS's responsibility, and what divides the orange from the blue is what we call like a management plane, and everything above the management plane is supposed to be the responsibility of the client, right? So here's a snippet here of defining for at least the Elastic Compute Cloud infrastructure. They're basically telling you here, you're responsible for making sure that you do the security configuration and the management tasks of those devices. Furthermore, if you look through their documentation, this is something I found regarding how they view digital forensics. If you read through this, it's a bit longer than what I posted here, but they really talk about logging, being part of their data that they collect for you in terms of digital forensics. They're not really talking about the hosts, right? And in fact, they even go further here and tell you that the responsibility to determine how the attack happened and the breach and what was compromised is very much your responsibility as a client. And they also go into briefly kind of cover topics around how can you recover from an attack, and we're here to help you to do that. But they're not really focused on doing the analysis piece, right? So when you look at the NIST model here, they will help you with detection, right? Because they have a lot of tools out there to help you with that. They might help you with containment because you're going to use their technology to possibly bring something down or terminate it or bring it into a secured location where you can examine the artifact further. And they might help you with eradication and recovery. But they really aren't going to be helping you, at least from a host-based perspective, on the analysis piece. And this is really what I want to focus this talk on is, what is it that you could do to help you get better insight into host-based forensics. So I developed this principle called SecDevOps Defense, SecDOD. In order to implement this properly, you really need to start thinking about how you design your forensic environments. Don't let them be homegrown and kind of evolve on their own. You really need to think about how you should structure your forensic environments, how they fit into the overall plan of your cloud infrastructure. A big component of that is, especially if you're a mid-size or a large-size company, you want to be orchestrating your forensic environment so that you can meet the demand. So if you have a large incident you need to deal with and you need to provide a lot of infrastructure for your forensic team, you want to be able to do that quickly. You don't want to have to order for more forensic towers, which will come 2 weeks from now and be installed in your forensic labs. It just doesn't scale anymore like that. So you really need to think about building orchestrating forensic environments. You also should be pen testing those forensic environments from the cloud. That's really important to do and make sure that they're secured in the way that you architected them and designed them. And one of the things that you should be thinking about is building and thinking about cloud forensic patterns. These might be really useful for you, the cookie cutter across different cloud environments as you start to grow your forensic environments in your space. So here's a pattern that I have I put together. So this pattern is showing you that the forensic infrastructure is still in the office, right? But all your SaaS has been moved to the cloud, and now the forensics teams are scratching their heads, thinking about how can they be doing threat hunting or forensics in the cloud when everything's been moved up there and your forensic environments haven't been moved yet. So you really don't want to be in this kind of position. So as you start moving to your SaaS-based infrastructure, you really want to start thinking about what things need to be done in order for your forensic environments to really connect and be able to, the forensic people to be able to do their job up in the cloud. So I try to design my forensic infrastructure in two different spaces. One is, we have an acquisition infrastructure space where you really use forensic tools there just to do the acquisition of host-based forensics, right? And that should be separated, and I call that a corporate gap rather than an air gap. That should be separated from your examiner infrastructure. And the examiner infrastructure may have even more variations of separation. Like you might have an infrastructure there that is used for malware analysis, and that might be air gapped, right? You don't want that to be spreading, and you want that to be very isolated as you examine malware. But your examiner infrastructure and your acquisition infrastructure should be not have a connection. And one way I solve that problem is, I use cloud services. Now, yes, theoretically they're connected because I'm using cloud services, but there is a degrees of separation there that help you maintain that integrity when you're examining something, and not having the fear that as you examine something it might actually leak out into the corporate network. So orchestration, this is kind of a design pattern how you might want to build your orchestration. You'll have a virtual environment that it lets you deploy on demand for virtual forensic clients. You'll have your forensicators that will log into some centralized controlling application that you built. This application should be tracking the inventory. You don't want to exceed the capacity of your infrastructure, your virtual infrastructure, or if you're in the cloud, you don't want to expand your on-demand to the point where it becomes a budgetary issue. It should be tracking your users, and as I always say, there should always be an approval process built into these kinds of orchestration mechanisms. I don't anybody that does forensics or is doing any kind of investigation needs to have an approval to do that. I don't want we don't want the forensic teams to be connecting to assets without there being some sort of approval or ticket for the work that they're doing. One of the other challenges, as I mentioned earlier, that a lot of software works on USB-based technology in order to activate it. So you might want to look at a network-attached USB solutions for that. Again, there's caveat because you need to make sure that that's not a problem with the software you're using. Some of the vendors might have a licensing violation if you do that, but for the ones that don't, you definitely need, that's one way to solve that issue there. So pipeline challenges with DevOps teams. You really you want to coordinate and collaborate with the DevOps architecture teams. In the past, I think there was a lot of separation between security teams doing their thing and the DevOps. The development teams are doing their own. It really need to start getting involved with the DevOps teams. I know there were a lot of talks at Black Hat last year regarding there being a need for security teams to make sure they collaborate with architecture teams. The architecture teams are trying to build in engineering solutions, right? And they're really risk weighted. You want to talk to them and introduce security solutions on a risk weighted way, right? So that you can, they can understand. In some cases they may, there may be overhead to be able to implement a security solution, but if the risk is not that high, then maybe you won't. You might bypass on doing that. Whereas other areas of solutions might need to be there because the risk is very high, and you want them to adapt those solutions into the overall overall design of the product. And you really should be doing security design so that you do it for security purposes and not just because you're trying to meet some kind of compliance requirement. And design into the pipeline. You want to design into the pipeline forensic solutions. Look at the forensic tools. A lot of those tools are actually really foreign to DevOps teams. They haven't ever been exposed to that kind of stuff, and there is a little bit of learning curve for them. And the methodology as well. It's the forensic methodology is very different than the normal DevOps deployment. The way they build software and their development lifecycle, it's very different than what forensic methodology is trying to do. And sometimes there's areas of clash there. So you need to work those out with your architecture teams. So what would a forensic tool pipeline look like? Really, you want to start at the beginning. You want to have a design. As the architecture team's trying to design some kind of technology, you want to introduce your forensic solutions into that, along with, just like you would with your other stuff, other operational needs like logging and alerting that need to go into that. You want to be prototyping that, and you want to be able to feed that back as a feedback loop into the design process until you get something stable. At that point, you'll want to you look at some automation In this case, I'm showing you Terraform, where you'll, as you build this solution, you might execute some automation tools with Terraform or with Packer in order to achieve the goal that you're trying to do here. And you want to test these security solutions and validate them throughout the development lifecycle here, in the test environments and the dev environments. And finally, hopefully you get something really solid that you can deploy to production, and your threat hunt team is able to do the thing they need to do, which is threat hunt. Okay, so baking process. You want to bake into the Amazon machine images. Creation process, you want to bake in all your tools that the forensics team is asking to be put in there. Tools to be able to examine file systems and do memory captures. Some of these tools, you can use open source. Some are, you might need to purchase them commercially. It all depends on what you've kind of decided to do in your organization. But basically, all these tools should be incorporated into the overall design of the base image. And the base image is what should really be getting deployed with all those tools on them out to your infrastructure. All right. So one area that also you need to think about is from a network perspective, you want to use tools like Terraform. Terraform kind of sits out on your perimeter of your account, and it is a way for you to automate making changes to, let's say, for instance, security groups. Like in this example, if I'm using F-Reponse, I don't want to have to bother the operations teams or the DevOps teams, and if we want to go and use F-Reponse to examine a particular node, we don't really want to be bothering them on a one-to-one basis, on a one-offs to get access to these hosts. You want to be using solutions like Terraform, where the perimeter already gets set up as a continuous availability back to your forensic acquisition infrastructure, right? So whatever tools you're using and whatever ports they need to connect to, you want to make sure that that's a very narrow subset of rules, but yet the rules need to be in place for you to do in order for your forensics teams or your threat hunting teams to have continuous availability to what's being deployed out in the cloud. All right, so I want to go into a use case here and walk you through how, two things I'll talk about here is software development lifecycle and how that might work, and the experience we had with this particular use case, and also on how this actually made a big difference between when I was talking about earlier about the shared responsibility model. Like everything below the hypervisor is, something that the cloud provider is responsible for, and everything above it, you're responsible. But sometimes the lines are a little bit blurry, and I'll show you here. And I think there was a big success here as a result of this, and the forensic community is going to be quite fortunate to be able to have this solution in place as we encounter some issues here. So the architecture team, what do they want to do? They wanted to drive adoption of a new EC2 instance, right? They wanted to move from Zen architecture to a Nitro architecture at the hypervisor level. They wanted to change the operating system from CentOS to Amazon Linux 2. And they wanted to, they really didn't have a choice. Nitro, defaults to XFS file system. So we used to be using Extent4, but now we're going to be using XFS. And the extended file system, they didn't want to build any partitions into that. It was easier for them to operate, expanding the partition sizes on demand. So this is basically, this was their requirements. Let me just go over some of this technology so it makes sense to all of you. So, the AWS's Hypervisor technology, originally they had come out with this technology called Zen. It really helped manage the hypervisor infrastructure from a software point of view. And Nitro's kind of changed that a little bit. They put a lot of what was being managed at the software level down into a lot of hardware components. And I found this visualization from Brendan Gregg. It's an interesting article to read about it if you want to deep dive more into the different types that they have and how they work. So what is Nitro in a nutshell? It's basically what they've done is they've developed a controller security chip. And they really, if you watch this YouTube video, it really goes into depth about the security benefits of Nitro. But basically what it comes down to is that they are creating this security layer between the hypervisor and the hardware, and everything that needs to communicate between each other is basically taking place through the security chip. And for various reasons that they'll explain if you watch this video, why this is really important to them from a security point of view. That's relevant to them, right? Not really exposing security to you as a client. It's not a security feature for you as a client, but just you'll know that if you use Nitro, it's more secure than Zen, right? The other thing here is, what is AL2? AL2 is Amazon's Linux 2. They've we've been using CentOS, but we were going to adopt Amazon Linux 2. There's a couple of reasons for that. There's some good benefits for that. It's really tuned at the kernel level for their infrastructure. They're going to support these core packages on a continuous basis, and they also say that it's going to be a lot less expensive than running other types of instances. So obviously it's attractive to the business to have a lower cost solution in place. File system types. Extent 4 has been around for a while. It's until recently, I think the Linux community has decided that even at the CentOS or level, that they're going to move to an XFS based file system. Nitro exclusively uses XFS. XFS is a file system that was invented by Silicon Graphics many years ago, and it's really good at handling large files. So Amazon's decided that they want to move in this direction. I posted here some blogs from Hal Prameraz. He's a Linux forensics guru, really doing a lot of good research in this front. If you want to learn more about some of the challenges here, and he talks about it in this blog about for forensics, you're going to have to be faced with dealing with XFS on a more common basis, and he goes into a lot of the details about how XFS works and why it's being adopted into Linux systems. Really highly recommend reading that. So what are the needs of the forensics team, right? The architecture team is thinking, hey, I want to build this new EC2 instance and start using some different technologies that the cloud provider was using. So you want to introduce your requirements, right? So our requirements are, we want to be able to do memory acquisitions on the hosts. We want to be able to perform a quick triages of the instances, like, on demand, be able to execute network connections that might be occurring on the box. And we also want to do host acquisitions of the assets in the cloud. So I'm going to talk a little bit about the first and the third. The second one, due to the time and so forth, I'm not going to cover it here, but maybe I'll do that some other talk in the future. So memory, from a memory perspective, there's really, on the Linux side, there's really two really good tools, Lime and AVML. We went with AVML. It seemed to work better for us on the AL2 side of things. We had been using Lime for the CentOS infrastructure. Again, here's an example of where the architecture team's changing something, but I gotta go and adapt my security tools, right? So we found that AVML was a better fit for AL2. Some of the challenges with this is as you go and patch your AL2 instances, you're going to have to rebuild the AVML in real time in order to keep that profile up to date. It won't work if the kernel version patch is in a different profile update than one you had previously. So that's something to keep in mind. You want to build that into your automation process as you as you go ahead and do the patching of these hosts. And also, you don't want to be dumping memory on the host that you're collecting the memory from. So you want to find a way to do that as a remote copy, right? This is, basically it's pretty simple to run this command. One of the things we found is we decided not to use the compression option. For some reason, it had problems running with volatility. And we used Packer to automate the builds of our hosts. I'll show you an example here of a Packer script that we're running in order to package and build the AVML into our base image. And again, I'll post these slides up on online later today. So host-based forensics. What we're thinking about here is that, there's various different tools for doing acquisition forensics. F-Reponse and Xways Imager. These, 4 of these are commercial tools. DD is obviously for free. It's native to Linux. We went with we started looking at, and I'll show you in this use case where we're looking at F-Reponse and DD to encountering some problems when we're doing host-based forensics on the Nitro infrastructure. We wouldn't have expected to run into a problem, but we did. So again, here's me, us running the DD command and how you might be able to. Here's another pattern, right? Think about these patterns and how can you run the DD command so that it doesn't drop the image on the host that you're trying to do collect a byte by byte image of that machine. So this is one way to do it. You can pipe it through SSH out to another host and drop the image there, and then maybe get out to an S3 bucket and out to your examiner infrastructure. So what is F-Reponse? Particular product we're using is called Universal. It supports Windows, Linux, and Mac forensics acquisitions. It also has this other feature set here. It looks like for some other cloud-based services that you can do forensics with. I haven't even started using that yet, but just wanted to show it here. It's a lot more than just for host-based forensics. They're moving into doing cloud-based forensics as well. So we went ahead and we started to do our testing, right? So we're going to test Nitro with F-Reponse, right? So here's a screenshot of what it looks like in F-Response. We see the different partitions, and we know that the root file system is on NVMe0N1PO1, right? So we go ahead and take an acquisition of that. See, everything seems fine. Everything seems to be working well. You get a successful image, no errors. But when I bring it up in Xways, which is the forensics tool that I use to examine the image that was created, the EO1, we're getting these errors, right? So we start getting these errors. We're like, this is weird. I mean, I don't have this problem with Zen, right? I take an image of the device with in a Zen architecture, and Xways looks at it fine, and then we're not really sure what the problem is here, right? This is in the early stages of our beta prototype testing, right? And what we're getting here are some missed size mismatch errors, right? And it complains about the sector size being less than would be expected at the boot sector. So that was really odd. Went back and forth with Xways and F-Response to try and understand what was going on here. Xways is one of the few products that supports XFS file system from an examiner point of view. And what happens here is it actually brings up part of the file system, but and as you can see there, the magic number identifies it as XFS, but it didn't bring up the whole root file system, right? So parts of it are missing. So I was able to recover part of it. Still not ideal, right? I want to get the whole thing. And so we're working here with F-Response troubleshooting, and more things popping up here that look kind of strange to them and us, and that's we're running this command line here that they have that kind of, I guess, it reads the block counts for their tool. And when we looked at the block counts in the proc partitions file, things didn't seem to match up here. So we were thinking, and if you think about it, that Xways error is talking about size mismatch. So we're thinking, something's going on here, and we're not able to get the proper block counts to make a good image, right? So maybe that's the problem. So one of the things that we did is I said, you know what, let's go ahead and do let's take a DD image of this of these devices and And there's another tool, it's an open source tool. It's called sleuthkit. It kind of does the same thing XWays does, but this one's open source and it's free. It lets you examine the file system. But as you can see here, at first we were like, okay, let's use sleuthkit, but sleuthkit doesn't, out of the box, the main branch of it right now doesn't support XFS. So, we can take an image and it's not getting us too far in terms of being able to examine it. But after some conversations with Hal, he informed us that there is actually a fork, an XFS fork, supported fork. It's not, at least since we last checked and a few weeks ago, it wasn't built into the main distribution of sleuthkit, but at some point it will be. But here's a link for you to go out to GitHub and get that if you want to use sleuthkit in order to do the forensics. But as you can see here, we created a DD image and we had no problem using the sleuthkit to look at the device, right, in the file system. So that kind of led me to think, this is not a problem with XFS. We went ahead and took the DD images and loaded them in XWays and they worked fine. We were able to view the image here. So what's going on here, right? So we noticed that, at least with the version that we originally had with F-Reponse, that we were only seeing the partitions and not the disks. So as you can see here, we're running the lsblk command. It's on Linux, and it lets you see the disks and partitions and the sizes. And we're not seeing NVMe0M1 in the F-Reponse console, and that was kind of odd. We're thinking, well, what's going on here? So we went ahead and communicated that back to the vendor, and they came back with a beta version, a patch version, and they started to identify, understand maybe what is the problem here, because we've been working with them now for quite a while on this issue. With their patch version, I'm able to bring up the disks, right? Not just see the partitions. And we took an image of the disks and we brought them up in XWays, and everything works fine. So, I think this is a big win, a big success for the community, for the forensic community. We've talked to F-Reponse. They told us that in their next release, they're going to provide this patch, and they're going to be able to support Nitro. So, and that's part of my point here, right? So, but before I get into that, let me just show you what the problem was, right? So, in the meantime, we're also talking to Amazon about this issue and have support tickets open with them, trying to figure out what's going on here. So, in their Nitro architecture, they went and they're starting to use NVMe devices, right? And they have this particular naming pattern that they use here, as you can see here. And this naming pattern was not being picked up by F-Reponse. Well, they were able to figure that out, and now their tool is picking up the right disks when you run their agent on the computer. And I provided a couple of links here if you want to learn a lot more about it. If you're in forensics, I would recommend you start learning and understanding NVMe devices. It's something they're relatively new, but they're becoming more common even in laptops and computers that are more physical in nature and less in cloud. So I just want to mention a few things. I think that, I've read a lot of research about how can you do forensics up in the cloud, and one of the ways that it's been communicated a lot is you can use this concept of snapshots, but I think that that doesn't really scale well. I think that it's, first of all, if the server's large, it's going to be slow to do that. There's a lot of manual steps, and you have to get, you're going to have to get the operations teams involved and help you mount those snapshots and give you an environment where you can work as a forensics person with those file systems. I just feel like there's better ways to do that. As I show in one way, we have a specific tool set in our environment that we use. F-Reponse, it's easy. It's quite straightforward to do that. But I'm not saying that snapshots isn't something you won't do. Maybe there's a need out there to do it that way. The other thing too is Lime. It just does. We ran into a lot of complications trying to get Lime to work on AL2. So I don't recommend that. Just stick with MVML. That might work better for you. And this wouldn't be a forensic presentation if I didn't have a lessons learned slide. A couple of things to think about here, right? Build into your software development lifecycle forensic solutions. I think you have to do that early on. It's really important to coordinate and collaborate with your DevOps teams, as you saw here. Even before we launched, hundreds of Nitro machines out there, we took the time to understand what impact it might have with our forensics tools and solve that problem before we started really shooting these out to all of our applications and replacing our Zens with our Nitros. You want to test early. You got to catch these issues. You're going to run into issues, but this is particularly interesting, right? So, this particular issue, right? So if you think about the shared responsibility model, well, you wouldn't think that this would have an impact, right? And originally, the architecture team's like, we're just going to go to Nitro. It's just another Linux environment. But the things that are happening below the hypervisor actually may have a significant impact with the way you run your security operations. And it's something that you don't want to be finding this out later when there is an incident and a bunch of Nitro machines have been deployed, and it might be difficult for you, or in this case, it wouldn't be possible to use F-Response. You might have to go to an alternate way of doing that forensic collections using DD, but that's a lot of manual steps, and it's not so easy to automate that using those sorts of tools. Automation is really important here as a lessons learned. You want to build in that availability so that my team can use F-Response in order to get to these machines in a way that I don't need to involve, the operations team. I don't need to, we don't need to bother the business, and we can on demand connect to any machine up in our cloud if we have to do a memory dump and then look at that memory dump, or if we have to do forensics on a host very quickly. I would say within 15 minutes, we can connect to a machine, create an image, get the image into our acquisition infrastructure. And then 5 minutes later, it's in our examiner infrastructure, and I'm using Next-Ways to start looking at, what might have happened to that machine, whether it was prompted by some alert that the SOC team got, or something like that. So within 15 to 20 minutes, we're able to do safe threat hunting. We're not bothering anybody. We're not bringing down systems. We're not making copies of the systems. Now, that gives us a tremendous amount of flexibility here. Just a couple of shout outs here. Cloud Village team, thank you for letting me do this presentation. I also, bunch of colleagues here that helped me with this and were involved in this in F-Response as well for coming out with a patch. I just want to thank you. I'm going to post a blog about this in a written form on my blog here. And if you have any questions, please feel free to email me.
Hey, Michael, quick question for me. Have you seen anything similar in terms of the pipeline that you built, or the tool sets, or just any other researcher implementing something like this for any of the other big clouds?
Yeah, I haven't seen anything like that. But then again, I have a little bit of experience in Azure just because we're also using that cloud service, but not with Google Cloud either. We don't have much experience in there. So no, yeah, my answer is I'm not really sure.
Got it. Because I'm assuming that it would be a little bit different because AWS uses their own proprietary hypervisor and all of that. So
yeah.
All right,
well,
cool.
Absolutely. So that's I think that's the the important thing here is, like, in order for them to scale economically, right? They're building their own hardware, right? Their own this is not VMware that's being deployed there. And as they do that, there's a concept of, hey, that's happening below the management plane, and you don't need to worry about it. But in reality, when you start looking at it like at a forensic level, right? When you're really examining at the device level, that might turn out to be important. And if you don't do this beta testing, if you don't do this prototyping before you deploy a fleet of machines on this new hypervisor technology, and you have a real incident, you're going to be struggling trying to do forensics or threat hunting in a quick manner.